And for this week, we're going to be talking about a different kind of probability. These ones are continuous probability distributions instead of what we talked about last week, that was discrete probability distributions. And for the most part in this, we're talking about normal distributions. So these ones have another function that you use on your calculator, or another two functions you use on the calculator. So everything I do is going to be with the calculator. You can also use the normal calculator in StatCrunch to do these. In this situation, we have the weights of 24-month-old boys. It tells us that they're normally distributed. That's important. And we have the mean is 26.9 and the standard deviation is 2.6 pounds. So first of all, we're trying to find the probability that a randomly selected 24-month-old boy weighs more than 25 pounds. In this, you do have to pay attention to the wording. More than is going to mean greater than in this one. So what we're going to do for these, and I really highly recommend this, is that you draw the picture. It doesn't have to be the greatest artwork in the world, but just draw your little normal distribution. So just draw a little bell-shaped curve. Put the mean right in the middle of that. Then shade in so that you can tell which direction this is going. So if we want them to be more than 25 pounds, go ahead and put the 25 on your graph, and it would be a little bit to the left of the 26.9. So I'm going to put it over here. More than means that we're going this direction. So I'm going to shade from the 25 to the right. The reason that this helps is that then this gives you some numbers that you can put into your calculator. So what we're going to use for this is the normal Cdf function. We always use normal Cdf. We don't ever use the normal PDF. And what this asks for is a lower bound and an upper bound. So this is where you can really use the picture to help you. Our lower bound is going to be where this region starts, which is at 25. And our upper bound, we don't really have one since this is going to keep going out to the right. So technically our upper bound is infinity, but the calculator won't let you put that in. So all you need to do is put in a really big number. So I'm going to use 10,000. It doesn't really matter what the number is, as long as it's more than probably 4 standard deviations above the mean, it'll work. So 10,000 is a nice safe value that you can use for most things. So there's our lower bound, upper bound, and then we need to put in the mean and the standard deviation. So we put in 26.9 for the mean and 2.6 for the standard deviation. So you have 4 different values with commas separating them. I went and got the normal CDF on my calculator, so I'm just going to fill this in. And if you didn't get that screen on your calculator, then you would have gotten where it says normal CDF, and then you just fill the values in and put commas between them. That gives us a value of 0.7675. And this should make sense with your picture. Remember that the mean is halfway in the middle, and that since this is symmetric, we actually would have 0.5 on each side. So since this is a little bit more than half of the graph, it should be something more than 0.5. Okay, next question is, what percentage of these boys weigh less than 22 pounds? Percentage means that you're trying to find a probability. So I'm going to do the same thing. I'm going to redraw my picture. And I'm going to put the 22 on my picture. Again, it's going to be to the left of the 26.9. And if we want the boys to weigh less than 22 pounds, that means we're going from 22 to the left. So I'm shading in to the left there. So I'm going to use my normal CDF. My lower bound, this time I don't really have a number for my lower bound, so I'm just going to use a big negative number. So I'm going to use negative 10,000. My upper bound is going to be 22. So I'm just looking at where I shaded in and putting the left end and the right end of that. And then I'm putting in my mean and my standard deviation. So, and since I already have this partly on my calculator, I'm just going to go up there and copy this, and all I have to change is the lower bound and the upper bound. So I still have the same mean and the same standard deviation. So this turns out to be 0.0297 for my probability, and that's the same as my area. If I want this as a percentage, I'm going to multiply this by 100. So that would be 2.97%. The next question is, what proportion weigh between 22 and 25 pounds? This time it's asking for a proportion. That's the same as a probability. That just means that we're not going to multiply it by 100 to get a percentage. We're just going to leave it as a decimal. Between 22 and 25, I'm going to put the 22 and the 25 into my picture, and I'm going to shade between those two. So this one is actually really easy. I'm still using my normal CDF. My lower bound is going to be 22 and my upper bound is going to be 25. And then I'm putting in my mean and my standard deviation. Same mean, same standard deviation. And this gives me 0.2027. And since it asks for a proportion, I can just leave it like this. This next question, this time it's not asking for an area or a probability or a percentage or a proportion. It's asking for a weight. And the weights in this problem were actually the x values. They were the numbers that we were putting here on our horizontal axis in our picture. So what this means is that this is giving me an area or a percentage or a probability, and it's asking me to go back and find the weight. So it's asking me to find the x. For this one, you also have to know what a percentile means. We talked about percentiles in the last unit, but a percentile, if it's at the 80th percentile, that would mean that 80% of boys weigh this weight, whatever it is, or less. That's the important thing about percentiles, is that they always go from the number, and it can be that number or it can be less than that. So that means in our picture we're going to the left. We want to put a number on here and we don't know exactly where it is, but if it's going to be 80%, that means it's more than half the graph. So it's actually is going to be somewhere above the mean. We just don't know how far exactly. So I'm putting that right there, and I'm putting an x in for that since I don't know what the actual value is. And there's the region, and that is going to be our 80%. So the area of this region, if I change this back to a decimal, that's going to be 0.8. The area of this region is 0.8. So that's the same as a probability. And this time, since I've got the probability and I'm trying to find the x value, that means I have to use the inverse norm function. So I'm going to go back to my distribution menu and find that. So that is number 3 on the list. I'm going to put in the area, and then I'm going to put in my mean and my standard deviation. So my area is what I found right here, which was the 0.8. And then I still have to put in my specific mean and standard deviation for this problem. So this one you only have to put in 3 values instead of 4. So this is what I actually put in here. And this turns out to be 29.1. Since everything else in this problem was rounded to 1 decimal place, I'm just going to round this to 1 decimal place. So this would be 29.1 pounds, since what we were looking for was a weight. And then last of all is, what is the cutoff weight for the heaviest 5% of 24-month-old boys? So I'm going to draw my picture one more time. And this one, again, they're asking us for a weight. That means that they're giving us a probability or an area, and we're going to have to use that inverse norm function. If we're talking about the heaviest 5%, that would mean on our picture that we're out on this end of our distribution. The heavier ones are out to the right. So we're looking for what this cutoff weight is, and we want this area over here to be 5%. So if we put that in a decimal form, that would be 0.05. The problem with the inverse norm function is that it assumes that you're going from the number to the left, just like we were up here. In this one, since we're going from the number to the right, we're going to have to change this around so that we know what number to put in the calculator. Because this entire area under the curve has to add up to 1, that means that if this is 0.05 over here, then this region over here has to be 0.95. So the area of this region is 0.95. If we use our inverse norm function and put in 0.95 for the area, it will still find this cutoff value for us. So I want to do inverse norm and put in 0.95 for my area, and put in my mean and my standard deviation. I'm going to put in 0.95 for my area, and then I have my mean and standard deviation. So this gives me 31.2. So that means that my x value right here would have to be 31.2, which means that if they're 31.2 pounds or more, then they're in the heaviest 5%.